6 is the final session in the series that we put together. We're obviously be creating new content to fill in some of the gaps, but today we're going to be looking at artifacts and the various things and reiterating some of the stuff that we had discussed in the past. And shall now start off. As we had talked about, there were mechanical artifacts. We talked about brain pulsations and breathing pulsations that can affect your recording. We talked about patient movements. We talked about bad connections. From an electrical standpoint, we can get signal saturation, static discharge, electromagnetic forces that can actually affect our recordings, and ground loops. We're just going to briefly kind of go through them again. This is the example I gave you of cardiobalistic activation, where the neuron is down here being recorded and our electrodes in place. And every time the heart beats, the neuron gets slightly closer and then further away from the contact, resulting in a change in amplitude over time. This is, again, an example of a chewing artifact. Every time the patient chews, we get this broad change across all the channels, very distinctive. I made the notion that connectors are a big problem, and the soldering and connectivity of these wires can be bad at the connector, in the cable, at the amplifier, in the electronics of the acquisition system, in the electrode itself. And do not overlook corrosion and dampness at the connectivity points. We talked about saturation of signal, where some large input can cause the amplifiers to shut off. And we're not recording any brain activity during this period. And then the amplifiers will reawake, and then we can record some brain activity afterwards. We talked about static electricity, the fact that you can build up a charge on one surface and then discharge. So imagine this being one surface building up, and then this being the patient. We have a change in transfer of electrons, and that will create a sharp intermittent pop in the recording signal. And this does occur quite often. And then we talked about EMF forces. They tend to be more regular in the signal. They can be irregular if it's a device being turned on and off. And those can be seen at different wavelengths depending on what's generating them. And we talked about how our bandpass filter, so we can create a filter that only keeps the frequencies within this range inside the box, and then outside it tries to dampen these activities. We talked about how sometimes if an external activity in this wavelength is so great, it may be very difficult to get rid of because these filters are not perfect. Keep in mind, our electronics are not perfect, our filters are not perfect, so we can't get rid of all noise in some cases, especially if the noise amplitude is very high, or if it's in proximity to our electronics. If there's one frequency dominating, it can occlude our ability to see anything else. We have to be concerned about sub and beat harmonics. So even though we have filters in a certain range, a higher frequency can actually corrupt our range of interest because of subharmonics. Ground loops, you need to be particularly careful about what's plugged in and on what things are plugged in on the same outlets, because those can generate noise. And we talked about that scenario where you have two things plugged into the wall and they share a common ground, and then you're trying to record and you're having this very complex interaction between all these devices being connected. So I put this up here. This is a book that was written by Montgomery, and it's generally related to the physiology conducted during deep brain stimulation surgeries. But the principles of noise, the principles of how neurons work, the principles about relating to single unit activities are consistent between DMS and the single unit, how we're recording single units on micro macro electrodes. And I would suggest that maybe just browse through this. The other thing that's really nice in this book is it has a whole section on troubleshooting noise, and it's quite extensive in how to look for it. For instance, if you see an oscillatory activity and the wiring going to the acquisition system is, somehow laying on the patient's arm, maybe that's generating some noise in the wire because of the movement. So you can move the wire. Are the wires going to the acquisition laying on other power supply lines? For instance, is the IV pole there and your wires going across the power supply for the IV pole? That can generate noise. So it walks you through different scenarios and the variety of different things that you can run into. And that's why I put this book up. It has a very thorough section. I think it's a good reading and a good step for understanding single unit as well as how to get rid of noise and other aspects of single unit physiology. So, given all that, I wanted to thank you for your attention for these 6 sessions. As I said, I want this to be a primer. I want to give you some ideas on what single unit physiology is about, how to get rid of artifacts, which is a big challenge when you're doing single unit activities. And I hope you continue to read and learn, in fact, move on in your journey for understanding neuroscience and neurophysiology.